chemistry.
Where I live, getting hydrochloric acid is difficult, so I decided to distill off some from cleaning products. These products contain between 5 to 10% concentration, and I would like a more concentrated version of it. So that's where azeotropic distillation comes into play. I can get 20% simply by distilling the acid multiple times until it doesn't get any more concentrated. So let's get started, and don't forget proper eye protection. For sealing joints I will be using PTFE tape. Use plastic clips because metal ones are gonna rust. Hydrochloric acid and water form a negative azeotrope. If we start distilling a mixture which is more dilute than the azeotropic concentrate, the residue in the heating flask will increase its concentration, while the distillate will have a lower concentration than what we started with. So my plan is to start heating the acid until I see that the temperature doesn't increase anymore, after which I will start collecting the distillate. After the temperature increased and a little bit of acid was left in the heating flask, I collected it and refilled the flask. I kept doing this a few times until I had collected a more concentrated acid. The temperature plateaued at 105.1 degrees Celsius, which is a bit unexpected since the azeotrope should boil at 108.6 degrees Celsius, but I guess that might be a problem with my thermometers. If anyone knows what the problem might be here, please tell me in the comments. So again, I collected the more concentrated acid, refilled the flask, and continued with the distillation. heating flask contains a yellow impurity. Now it's time to do one final distillation of the collected concentrated acid to get that clean azeotrope. The temperature reached 105.1 degrees Celsius, and I decided to leave it for a little bit to see if that will change, but it didn't change. So I decided to collect the acid. Just as I swapped the receiving flask, something very strange happened. The temperature began to drop, indicating a drop in the concentration. Now, I can't really explain this. Because water and hydrochloric acid form a negative azeotrope, this really shouldn't happen. So I decided to redistill the first higher boiling fraction plus the remaining of the higher concentrated acid that I had already collected. If anyone knows what's going on in here, please tell me in the comments. This time the temperature plateaued yet again at 105.1 degrees Celsius, but this time it didn't drop, and none of the remaining fractions that I distilled did drop. After the distillation almost completed, a yellow residue remained in the flask. And I repeated this process with the remainder of my more concentrated collected on the site acid. To determine the concentration, I measured the density using a measuring cylinder and a scale. I poured the acid into the cylinder using a pasteur pipette, but that turned out to be not such a great idea because the acid stuck to the walls. So after I poured the acid, I took a napkin and wiped out the edges. I measured 5 milliliters of the acid, and then I took a measurement on the scale. As it turned out, the density was 1.2124 grams per milliliter, which is a bit too much. I also measured the temperature using an infrared thermometer. And then I went on to this website to calculate the concentration. And as it turned out, something was wrong because the density was outside of the given range. So I figured something was wrong with my measuring method. So I decided to try out with two scales just to compare the results and also use a more precise volumetric pipette. I took the measurement of the empty beaker, then I poured the acid The first acid was used to rinse the pipette a few times. So here I sucked up a bunch of acid and poured it into a disposable container just to rinse the pipette before I use it. And now I poured acid in the beaker, which will actually be used in the measurement. So this is what the technique that I will use to suck the acid and then move my thumb to measure out the correct volume. Okay, I sucked up the acid. Now you can see the same thing from a different angle. And now comes the hard part. I have to precisely stop, lift my thumb only a little bit and stop at the correct mark. I have to do this really steady. And here we go. Now I'm pouring the acid in the beaker, which I will use to measure on the scale. At the end of the pipette, a drop remains. This pipette is actually designed for this to happen, and it's important not to try to push that drop into the beaker. Actually, I took the measurement 3 times and calculated the average. Here are the results, and I put the numbers in the same calculator, and I got 18.2% concentration. This got me thinking, what if handymath.com suddenly decided to disappear? I'd like to have a calculator like that because it seems very useful. So I decided to reproduce it. I did it in Python using RegularGridInterpolator. I took the data from this table, put it into a CSV file, and that's how I created this script. Let me give you a little demo. So for temperature, let's say 36, and density, let's say 1.08739. This is the predicted concentration, and let's try to put the same numbers in here. Okay, 36, 1.08739. Let's calculate. And as you can see, the predictions are the same, or extremely close, up to 4 digits after the decimal point. At the end, I decided to say fuck it and label it as 18% to 20% acid.